So the conduction system of the heart begins with the right atrium. The signal starts in the back side of the SA node, or we can call it the natural pacemaker of the heart. So the sinoatrial node. The sinoatrial node is autorhythmic. What that means that they can generate an action potential on its own without a nervous input. These cells, they send an action potential all around the right atrium onto the left atrium. They cause the action potential to be propagated all around the right atrium and the left atrium. All the atria are now depolarized, and they contract and squeeze the blood into the ventricles. The right atrium then pass the signal down to the AV node, and the AV node is travel to the centers of the heart, to the bundle of His. So the AV node and bundle of His. When they travel down to the bundle of His, they then split into the left and right branches, and from the bottom of that branches it take a U-turn and travel up into the Purkinje fibers. It will travel up to the top of the right and left ventricles. So the last area that will depolarize and contract are the right and the left ventricles. So the contraction first occur in the atriums. They squeeze the blood down into the ventricles. The ventricle then contracts and pump the blood up and out into the pulmonary and the aorta to go to the systematic and pulmonary circulation. So the AV node is the only connection from the right atrium to the right ventricle. It is to get a signal to the ventricles. The AV node will slow the action potential down to give time for the atria to push the blood into the ventricle, to make the ventricle full of blood between it can pump in and out to the pulmonary trunk and the aorta. It makes it harder for cells to reach a threshold. The sinoatrial node has the unique ability to being able to generate action potential spontaneously because their resting membrane potential is unstable. They can automatically get to threshold because they need sodium, and sodium will leak into the channel. So they have the long absolute refractory period, which is there will be no action potential at that time. So in the cardiac muscle action potential, the sodium channel will open and we'll have a fast depolarization. When they reach the threshold, the potassium channel will open and then potassium will start to rush in, but then the calcium channel would also open. And these calcium channel open will cause the sodium channel to turn off. Therefore, it can elongate the depolarization period by adding the calcium channel. As the calcium concentration gradient moves to equilibrium, the potassium is still going to move out, and eventually we'll have a decrease in charge, and that's going to close the calcium channels. So the calcium can only move until the gradient gets down. So the sodium begins to deactivate as the calcium channels open, and those sodium channels that stay deactivated for almost the entire length of that plateau. So that also helps with that absolute refractory period. So we measure the movement of that actual action potential through the heart with an ECG. So people put electrodes over the skin to measure the movement of the electricity, and it's end up being this measure. This doesn't show directionality, but it just shows the movement of charge as measured over the skin, so that this is will measure the waves. The ECG is called electrocardiogram. It means that it's electrical heart rhything. It used to be EKG. Since cardio is written in German is K. So the x-axis is time, and the y-axis is the voltage. And this is looking as the whole heart. So the first pump is called the P wave. And this is the depolarization of the atria. So this part right here is when it's depolarized to the right atrium to the left ventricle. And this whole electrical activity we are looking at is called the QRX complex. And this is when the ventricle are depolarization. The atrial is repolarization, but since this is a huge electro activity, so it kind of masks the way that the right atrial is repolarized. This is when the signal passes down and up to the ventricle walls. And the last pump is the repolarize of the ventricle. It is called the T wave. And this is when the ventricles are repolarizing. So they are regaining their negative resting state. The atria also repolarize, but they repolarize while the ventricles are depolarizing, so it's kind of covered up. So the important thing is that the electrical signal or the action potential always come before the physical movement. So we always have to have the electrical signal before the beat, so the atrial can depolarization. So the T wave, which is when the ventricular begins to repolarization, and this is when the potassium is exiting those cardiac cells and the charge inside the cell is returning to negative. So we try to returning to the negative resting membrane. And this is the representation of the movement of ions, not the contraction of muscles.